Welcome to the video lecture on Programming in C. In this lecture, we are going to discuss the role of function arguments and return value. The need for arguments and return values arises due to the limitation of local variables. As we have already discussed, the usage of local variables is confined to only one function in which they are declared. That is the scope of local variables. They are neither visible nor accessible outside their function. In this example, we try to compute the sum of x and y variables from the sum of xy function, but since they are declared inside the main function, their scope is restricted to main function, so we cannot access them from the sum of xy function. This leads to an error message stating that x and y are undeclared. We can overcome this situation in two possible ways. The first option is to convert the local variables into global by declaring them outside the main function. But as I told you earlier, we should avoid global variables since they retain memory for a longer period. So our next option is to go for function arguments by forwarding the values of the local variables to the called function. Now think of a similar situation that happens in your life. Imagine that you apply for a job at a company in Delhi and you are supposed to provide your certificate for their verification. But the certificate is with you at your hometown and so they can't verify it from Delhi. What we generally do in this situation is to make a duplicate copy of the certificate and send it by courier to the company. They will receive the copy of your certificate and use it for their verification. Because the copy has exactly the same content of the original, it is enough for their verification purpose. But since the copy and original are physically different, even if the copy is modified or tampered, the original remains unaffected. In the same way, when some values of the calling function are needed in the called function, we can pass those values using function arguments. Arguments are also referred to as parameters. Now I have modified the program by sending x and y from main function as arguments of sum of xy function. To send arguments, we just have to list the local variable names that need to be passed between the brackets following the function name and the function calling statement. If many local variables need to be passed, then we should separate them using comma. Similarly, to receive the arguments from the calling function, we should declare variables at the called function within its brackets. But this time, we should also mention their data types. This causes memory getting allocated for the x and y within the sum of xy function. Then the values passed from the main function are copied into them. Now the x and y of the main function and the x and y of the sum of xy function contain the same values, but physically they are different. When the z value is calculated, compiler adds the x and y values of the sum of xy function, which is equivalent to adding x and y of the main function. And now the result is properly displayed. But just like the certificate copy, changes made on the copy of values received at the called function has no impact on the original values at the calling function. In this example, x and y are modified to have 0 at the sum of xy function, but this modification has no impact on the x and y variables at the main function since they are physically different and have their own memory locations. So their values remain the same. This method of argument passing is also called call by value. Now we are going to learn about how a called function may return a value to the calling function, which is probably the result of its calculation by manipulating the arguments it received. Though the calling function can send any number of arguments to the called function, a called function is limited to send only one value to the calling function. This can be done by using a return statement. Its syntax is return followed by either the name of the variable whose value needs to be returned or the value to be returned. Let us look at some examples. This returns the number 5 to the calling function. We can also return decimal numbers. Characters can also be returned. We generally return 0 to indicate something to the calling function. It is even accepted to provide an arithmetic expression with the return statement. In that case, first the result of the expression will be calculated and then it will be returned. In this example, 10 will be returned if x and y are equal to 5. C has a rule on the use of return values. Programmer must mention the data type of the value that is going to be returned from a function. It should be mentioned before the function name at the function definition. Even if we have no plan to return any value, we should inform the compiler that nothing will be returned by mentioning void as its return type. Void indicates that no value to be returned by a function. But when we wish to return an actual value, we must mention its data type before the function name. In this example, main function does not return any value and so its return type is void, but sum of xy is going to return an integer value, so its return type is mentioned as int. Note that no return type should be mentioned at the function calling statement. Only at the function definition it is needed. When a function call receives a return value from the called function, it should be captured into a variable by keeping the function call at the right side of that variable in an assignment statement, so that we can display the received value to the user. We can avoid the declaration of z since we can directly add x and y at the return statement itself. When a function call returns a value, it can be directly placed in the printf function without using any intermediate variable. But note that a void function cannot be placed in a printf statement like this. Arguments and return values allow us to indirectly extend the scope of local variables so that they can be used from multiple functions. This prevents us from going for global variables.